Question 2 is coming from transformations of functions. The diagram shows two curves. One curve has equation y is equal to sine x, and the other curve has equation y is equal to f of x. So this is the one for y is equal to sine of x. Okay, and then this one is y is equal to f of x, the transformed one. Then they are saying that part A, in order to transform y is equal to sine of x to the curve y is equal to f of x, the curve y is equal to sine x is first reflected in the x-axis. Describe fully a sequence of two other transformations which are required. Now, when you transform the graph by reflecting it in x-axis, that means the y-coordinate becomes a negative. Okay? You have a point here, you reflect it in the x, then it will be this side, right? So it's still the same x-coordinate, but the y-coordinate has changed the value. It has changed the sign. So as simple as that. Now, let me write something here. Reflecting in x-axis. This one simply implies that y is now going to be equal to negative sine of x. So when we do so, to reflect it in x-axis, this is what we are going to have. Let me use another color here. This one here is on a 0, even that will be that. So this one will be here, then here, then here. Where else? We have here, then this one here, we go down here, then here, and then there, then here. So we are going to first have this graph here going like that when we reflect it in x-axis. That is what we are going to have, okay? Then you can see that this one was stretched, okay? But now let me take you through the process of transformation of these trigonometrical functions. Now, suppose I have my graph here, and I'm going to use that one of y is equal to sine x. So sine is here, then x. So this is the one here, okay? That is the one there. Now, when we look at this other one here, we can see that for sine x, its period, okay? Its period here is the period, you look at the degrees it takes for it to repeat itself. So from 0, then it comes to, this is 2 pi, then again it continues. So the period is 2 pi, okay? Now, when we go to this one here, and let's say we say y is equal to sine of, let's say, 2x, okay? What happens to the period? This one repeats itself every after, check here, every after the blue one, sine 2x. Now it is here pi. From here, okay, from here, then to here. That is now pi. Again, it repeats itself every after pi. That means the period is going to be, the period is pi. For the original one, the period is 2 pi, okay? That means if I have something like y is equal to sine of, let's say, b of x, okay? How do I get this value? We have seen from our graph here that when you get the period of the bigger one, I mean, when you multiply this one by 2, the period now becomes 1 over this value here, okay? Because it was 2 pi, now times, since this is 2, it is going to be 1 over 2, and then we are getting what? Pi. So that means to get b is going to be period of original curve, okay? Period of original curve, then divide by the period of the transformed curve. Okay, the period of the original curve is 2 pi. This one of the transformed curve is pi. Do you see how we get the 2 that is here? Okay, so that is that. Then also when we transform this one, maybe by a sketch, okay? I mean the stretch, not sketch. Let's say we use stretching. Stretching is just multiplication, okay? Now, I'm going to use y, let's say, is equal to 2 sine, okay? 2 sine of x. Now, let me first take off this one here. Now, I want you to look at the period here. I mean the amplitude. Amplitude is that distance between the highest point and then the principal axis, okay? The principal axis is this one, which divides the graph into two, whereby the crest here is equal to the trough, okay? So that is that. Now, you can see that here it is 1 unit, but then this one, it is 2 units. So what we have multiplied with here is actually the amplitude here. You see that? Now, let us also see how you can get, so this one here, the stretch in the y is the amplitude. And then let us also see what happens to when we transform this one here. Transform, let's say I get y, okay? I'm getting another one. Y is, let's say, equal to sine of x, then plus, let's say, 2. You see? Plus 2. Now, this one was taken up, okay? That is a vertical translation. So, when you look at this line here, y equal to 2. That line, y is equal to 2. It is the one that divides this one into 2 equal parts, right? So, look at what is here. This is again 1, and this is again 1. But this line here, the vertical translation you have done here is actually the transformation you are having here is the principal axis. So if I have y, which is equal to a sine bx, then plus c, this one here is the principal axis. Principal axis. And it is the vertical translation. Okay? Vertical translation. If you want to know how to get it, you can get the maximum point, then plus the minimum point, divide by 2. So the maximum here is 3, right? Then the minimum here is what? 1. So plus 1, then divide by 2. Don't you get 2? This is the one here. You see that? Then this one here, the b, I've already told you, it is the period of the original curve divided by the period of the transformed curve. And then a here is the amplitude. To get the amplitude, you will get the maximum point, then minus the principal axis. The principal, okay? Minus the principal axis. You see? Like here, it is 3, then minus the 2, then you get this one here. Okay, now let's go back to what we are given. Now look at the transformed curve. Let's look at its amplitude. Okay, amplitude of the transformed curve, Okay, that amplitude is going to be, we have to get, first of all, actually, before I get the amplitude, let us get the principal axis, right? So the principal axis of transformed curve. Remember, I said you get the maximum point, then plus the minimum point, you divide it by 2, okay? So the maximum point here corresponds to 1. So I will have 1. If I have something like y is equal to a, let's say sine bx, then plus c. So I'll have 1, which is that c, right? 1, then plus the minimum is this negative 5, then divide it by 2. So get negative 4 divided by 2, that is negative 2. So this line here, okay, let me draw a line here. Y is equal to negative 2. This is the one here. That is the one that divides this into 2, okay? Y is equal to negative 2. You can see that this one here is equal to that one there. Now that is the amplitude. So amplitude is going to be this one here minus negative 2. 1 minus minus 2, which is equal to 3, okay? And we said that amplitude is this stretch here parallel to y-axis, okay? So this simply implies that we have a stretch by factor 3 parallel to y-axis. You see that? So I will say this is therefore stretch by factor 3 parallel to y-axis. Okay, so it has been stretched. If it has been stretched, now this one here is negative 1. So times 3, then we expect it where? We expect it down here. Negative 1 times 3, that will be negative 3. So we shall see it here. Then, of course, here 0. I need a new color. Let me use blue here. It will be here. Okay. Then, again, this one here. Y here, of course, times. We are multiplying by 3. 0 times 3, it will be here. 1 times 3. That one will be maybe up there on 3. Okay. And then even here it will be there. Then here, and then this one up there. So we shall have something like this. Like this. Like that. Then it goes up there. Like that. Then that. After stretching by factor 3 parallel to y-axis. Then we are seeing negative 2 here. So that means it was moved down by 2 units. Okay. So minus 2, each y coordinate minus 2. This is a 3 here. Okay. This one here is a 3. Then minus 2, you will get that one. 3 minus 2, you get that one. You see that? Okay. So that means since it was shifted down by 2 units, then we shall have translation by vector 0, negative 2. Okay. But you could also get that one from the principal axis. Okay. Which principal axis we got as negative 2. That is the one I told you here. Okay. So I would say that since the principal axis is y is equal to negative 2, then y is equal to negative sine of x was moved downwards. Actually, there is a 3 here because we have already stretched. Okay. It was moved downwards by 2 units. Okay. So the other transformation, remember, one transformation is here, then the other one is translation. This is therefore a translation by vector 0, negative 2. Okay. Translation by vector 0, negative 2, stretch by factor 3 parallel to y-axis. So those are the ones. Then find f of x in terms of sine theta. Remember, at first we are having this one reflected in the x-axis. So we have y1, which is going to be negative sine of x. Okay, because we have y is equal to negative f of x, which is reflection in x-axis. Okay, y changes the sign. And then the next one here, we are having stretch, okay, by factor 3 parallel to y-axis. So that means we shall have minus, so you put a 3 here. So times 3, you have 3, this one here, and here we are having stretch by factor 3 parallel to y-axis. Okay, what next? Now we translate with this one here. So we shall have this one here, then minus 2. Okay, that is the translation by vector 0, negative 2. So meaning that we shall have our f of x, which is going to be equal to minus 3 sine of x minus 2. That is that.